Hello. Hello. Yes, we're on. Okay, excellent. Welcome back, everyone. So, we're going to have a panel. We're going to have a panel discussion. So the topic that we have is the importance of software engineering good practice in climate science. It's quite a leading statement for a panel, really, isn't it? What we should say is how important is software engineering good practice in climate science. But that's what we're going to explore in this panel. So I'm going to briefly introduce myself, and then I'm going to hand along and let the panel introduce themselves. So my name's Paul Richmond. I'm the engineering lead in ICCS. So prior to coming to ICCS, only kind of 6 months ago, I think, Chris? Yeah, 6 months ago, I was a professor of research software engineering at the University of Sheffield. So my background is in kind of building engineering teams, research software engineering teams, and that's what I kind of did in my previous role. And now I've kind of left them to it and come to build a new team in ICCS. Kirsty, I feel like we should skip you because you've introduced yourself and go over to Chris, if that's okay.
Okay, surprise. So my name is Chris Edsall. I'm the head of research software engineering within Research Computing Services here at the University of Cambridge. I've been involved in the area of computing and software and climate science since last millennium. I just edged in. I started at NIWA in New Zealand in 1999. So 13 years in atmospheric research and oceanography institute there. Did a couple of years at Southampton Oceanography Centre in the UK. Moved to Bristol and saw the light of research software engineering. So it was interesting at NOC that we had a desperate need for research software engineers, but we didn't know the name of it, and our funding organisation didn't really appreciate the need, but it was there. And then 2 years ago moved to Cambridge and lead basically 3 teams of research software engineers. So we've got the core team who are cross-discipline, any domain. A group in the Cambridge Open Zettascale Laboratory, which are looking at high-performance computing, in particular researching next-generation HPC systems, and also helped kick off with some people from my existing team, the RSEs in the Institute of Computing for Climate Science. Sadie.
Hi, I'm Sadie Bartholomew. Unfortunately, I wasn't able to make it yesterday, so you might have just seen me now, not seen me around. So I work for the University of Reading, and as part of a centre called the National Centre for Atmospheric Science, which is a UK centre which is distributed across various UK universities. So me being based at Reading, but others might be at various different universities. So my job title is computational scientist. But actually this is effectively a research software engineering role. So I am an effective RSE. So I've been working as an RSE for, I think, just over 5 years now. So I've been at Reading for 3 years, or 3.5 years. Previous to that, I worked for the Met Office in a similar role. So day to day, currently, and for most of the time I've been at Reading, I've been working on projects that cover. So ultimately, I'm creating tools that help climate researchers to do their research. For example, I work on some libraries that enable data analysis and visualization under some metadata standards called the CF conventions. And I also work on projects which facilitate documentation for climate modeling efforts. Yeah, I think that about sums me up. Thank you. Marion?
Yeah, my name is Marion Weinzierl. I am senior RSE at the ICCS. I am a computer scientist by training, did my PhD in parallel numerical solvers in computational fluid dynamics, and then a postdoc in solar physics and space weather prediction. I moved to industry for 2 years in a X-ray technology startup, and then came back to be an RSE at Durham University, where I've also done the RSE theme lead role in the N8 Center of Excellence for Computationally Intensive Research, which covers the 8 research-intensive universities in the north of England. And I've just joined the ICCS 2 weeks ago, so I'm meeting everyone for the first time. I've not yet been assigned a project, so it's really interesting to be here.
Thank you very much, and thank you, panel, for agreeing to come along and answer some questions. And since we've got such a good panel, it would be such a shame to not have some really difficult questions. So don't give us the easy ones. Like, we have this thing called Slido, and I think what we're going to do is we're going to take the questions via this Slido system. So you can see there's a QR code up there, or if you go to slido.com, there's kind of a few numbers you can put in. It will take you to this poll. So are any of you Redditors out there? Anyone use Reddit? So the system's a bit like Reddit. So one person, so the reference will be totally lost. But you effectively can upvote the comments. And the ones that people want to ask, so as you're sat there, you can ask your own questions, or you can upvote the comments that are there, the questions that are there, and they'll float up to the top if lots of people want that question to be asked. So it'd be really nice if they weren't all anonymous. If you put your name against them, then I'll ask you to just give us a little wave before we ask the question. And that'll be useful because then, we can look at you and know who you are, and then also understand whether or not we've answered the question or not. But also, you can ask an anonymous question, which means you can ask a really awkward, difficult question, or something that you think is obvious and you're a bit embarrassed. Just ask it anyway, and if other people are thinking the same, we can float it up to the top and ask it. So off you go, ask some questions. I'm going to pick one that's already there. I'm going to go for the top one. Controversial already, I like it. In an ideal world, there would be no RSEs because researchers have learned the important software engineering techniques, or would each research team have their own RSEs? Okay, so who are we going to start with that? Chris, you run a whole team of RSEs, so I'm going to hand that over to you.
This is an existential threat to me, really, isn't it?
to all of us, perhaps.
Yeah. I can't help but think of that question sung to John Lennon's Imagine. I'm not going to sing.
Please don't sing.
I think there will be a place for people who have a specialism in RSE. I think that will continue. The reason being, science is a team sport. The concept of I'm going to be a little bit sexist here because this is from the 18th century. The gentleman scientist, the individual scientist who has the leisure time or the funding and the experience to perform all of the science themselves in isolation. They work away with their flasks of whatever chemicals or whatever and discover some new gas and publish it, and that whole thing is done by them in isolation. I don't think science can be done that way. It has to be done as a team of people, and within a team you can have different specialisms. So I expect there will be more embedded RSEs. So I expect each science team to need somebody for whom that's some fraction of their job, maybe a majority. I see the value in a central RSE team in a university, or maybe in a commercial research institution, where individual science teams or departments or groups don't really have enough funding for a dedicated RSE in their team, but still have the need of that knowledge and experience.
So you're covering quite a lot there about the kind of the equitable access to RSEs, if you like, and you're referring to what I like to call the computational elite, those that have lots of money, lots of resource and access to kind of RSEs. But what about the fact, can't we just train all researchers to be RSEs? Perhaps someone else, can we train all researchers to be RSEs and then we don't need RSEs at all? Marion? You're looking at me.
Well, I put that question there.
Okay. Well, you can't answer your own question, sorry.
Well, I can say what I think about it a bit. Yes, it's something that I'm thinking about quite a lot. So my previous work, I've worked in a central team, and it was not just for computational scientists that we worked, but also for people in all departments. So I was on projects with the music department or education or things like that. And I think there you can really add a different kind of value because the people are not computational experts themselves. Whereas if you're working with a computational physics team or a computer science team or so, for example, on one of the Excalibur projects or so, the people you work with are experts themselves, and doing this project work where you dip in and out actually has some context switching overhead. I think also the PIs are sometimes a bit unhappy about the amount of work they get out, but then the line between a postdoc or a PhD student and RSE gets really blurry. So, and there's this notion of having researcher developer versus an RSE, and where is the difference really? So it's actually a question that I have and that I have my thoughts about, but I don't have the answer. And I do think in computational science that embedded RSEs are actually a really important thing and can really add value, but you need somebody with a hat on that shouts, stop, we do have to do tests or so, because otherwise you can get really driven into the no, we do need the next step there. But sometimes the computational scientists also are already RSEs in some way. So,
okay. So, Sadie, at NCAS, is everybody already a competent research software engineer?
I don't mean to speak ill of many of the researchers in the institution, but I think they have goodwill and they would like to be competent researchers. But I think for me it's about time and effort, and obviously not everyone, well, nobody has infinite amount of time and effort. And to me, to be both a researcher and an RSE, that's already 2 jobs, I think, or even more than 2 jobs. I think in an ideal world, and going back to the original question, in a utopia for me, I don't think it would be possible for people to be essentially both of them at once, purely because in domains of research, for example, climate science, the science itself is already so complex, and to be at the forefront of leading research and to follow updates on research and the latest papers, that's already a job in itself or more, as well as keeping up with good practice and the skills you need to do software engineering. That's already, I think, you'd be brilliant if you could keep on top of all of that, but I think that would just be too much. So I think for me, it would always be about having access to both researchers and relevant software engineering research software engineers, whether embedded or in a separate group. So for example, at NCAS, we don't have these embedded software engineers. We have our group and another group for called CEDA, Centre for Environmental Data Analysis, which deal more with, I guess, the data side, but it's also related to software. 2 separate groups which can be called upon when useful, and we help the whole organisation. So it doesn't have to be embedded, but I think, as Marion was saying, embedded research software engineers, I think, are a fantastic idea. Potentially not in all contexts might be the best solution, but I do think one of those 2 or some sort of hybrid would be necessary. Okay.
So, Kirsty, we're not all going to answer every question, by the way, but this is the first question, so I want to be fair and ask everyone. The SSI then does a huge amount of kind of advocacy about kind of good software engineering practice, Kirsty. So you must have a good statistic from one of the surveys that says just how prevalent software is. I think you already possibly had it on your slide. I can't remember the number, but is there a base level that everybody should have, no matter what domain? Is there a base level of competency, or does it differ by domain?
69% of researchers partly software is essential. I don't think you can go into other academic domains and say you should be doing this, because they're the experts. They know what they're doing and they know what they want to do, and academics hate being told what to do as well. So all you can do is work with the communities and see and understand where they're trying to get, and if software could help them get there. There's fields where software wouldn't help, that's fine. And then you can start to understand the software practices. So that's what the SSI tries to do with the fellowship scheme, because they train people to be ambassadors within their own research domain. It's really domain specific. I think in something as complex as climate science, you can't do everything, and we try so hard to do everything, but you just can't. You can't be an expert in all the physics and all the interpretation and all the software engineering skills as well. So I think and as people are learning more, as people are getting more advanced in their software skills, the computational stuff is getting harder as well. So I think that's moving on. So as we kind of catch up, as a researcher, I'm always playing catch up. I'm like, as soon as I learn something, it's moved on and I need to learn something new, both in terms of the science, but also in terms of the software that I'm using and the tools that I'm using. So, I mean, I think there's a huge role to play in having someone that's ahead of the game that can kind of like pull me up, because it's so important in terms of training and peer support that people can kind of lead by example and teach by example, which is a really useful way of learning.
Thank you, Kirsty. So I'm going to move on to our next question then. So this one's from Tom. Tom, do you want to give us... okay, Tom, yep. So this question is, what steps can we take to address lack of diversity in the RSE community without also putting additional pressure on minorities that we have? That's a really important question. So rather than me kind of randomly pick people, if you particularly want to answer a question, you're going to have to give me a sign, give me a wave, or a hand up, or you should have a little flag or something you could put out. But does anyone particularly want to have a go at this one? Chris?
You could be not here, because it's either at 10 o'clock or 11 o'clock. I think there's a webinar today run by Diverse, and I can't remember the name of the speaker, but it was actually something about putting numbers on. The reason I don't know the name of the speaker and the name of the topic off by heart is because I saw it and I thought, oh, well, I'm at summer school, so I can't go to that. But if I weren't here, I would be at that, because that looks very interesting. There is not a lack of resources in the community for advice for this. Certainly, I look at myself as a stale, pale male, an overrepresented demographic, and then I look at the recruitments that we're doing and the people who are applying, and it's hard. So we do make a conscious effort to, in respect to recruitment, to advertise in areas like women in HPC, women in science and engineering, that sort of thing. One thing that has worked well for us is being more flexible in employment things. So we've got somebody on the team who has caring responsibilities, works 70% time, and they would not be able to work for us if we weren't able to offer that. So, and also flexibility in location allows us to look at a pool who aren't just based in the case of my example, in Cambridge.
Marion, I really hope you're going to talk about some of the things you've done at the NA.
Yes, I feel I need to say something here. So I, in my second year as a trustee at the RSE Society, I was the EDI lead, and with the team we had there, we developed a strategy draft, we called it, because we still felt that it's just a starting point and hopefully will be continued. And also in my RSE theme lead role in an HCIR, I was the head, also founded the Women in HPC chapter, which actually Kirsty started the efforts. I always want to attribute. So we've done, so Women HPC is doing quite a lot of things in terms of advocacy for diversity and inclusion and the high performance computing community, and they run regular workshops at the big supercomputing conferences where they have early career talks and posters, and there is a mentoring scheme where each of the early career speakers get assigned a mentor, which really helps basically giving people the confidence and the platform. And over the years, really, the uptake and the interest in this has really increased, and we've been having additional workshops, for example, at the SSI collaboration workshop and at CIUK and things like that. So that is one thing, to create this space and to discuss these things. But I feel often you really also need to give people something concrete. So what we did in our chapter was putting together a recruitment checklist. So just to basically give certain steps that you can do at the beginning of your recruitment process, in your advert, in your interviews, and so on, and which will start just a thinking process. So there are a lot of things that you might just not think about when you create a project or a position, and so on. Things like Chris said, flexibility, and I think an RSE job, because you're often not 100% on one project, but you're often on 2 or more, so you can easily do a job share or do flexible working, things like working remotely. So I still live in Durham. I've got children who go to school in Durham and so on. I wouldn't have even applied for this position if there hadn't been the possibility to do this remotely. But yeah, generally there are so many more things to diversity. So of course there's accessibility, there's basically the overall inclusion of all kinds of different people, and so you do need to be open. And I could talk. I could talk an hour.
Could I just say
okay.
A big thumbs up for the checklist, for the recruitment checklist. I use that like every time I recruit. It's a fantastic resource, so you should all look at that. It's called the N8.
So EDI recruitment checklist. So it's on the Women in HPC website under resources as well, and under resources there are also lots of other resources in that direction. And generally all of the Women HPC events, I think, if you go along, there are always really good discussions about these topics as well.
No, you can't go again, Chris, sorry.
We haven't mentioned the second half of the question. I was just going to refer people quickly to Kristen Merritt from Alsace Flight has a good presentation on what she calls the diversity tax. Yes. So we should not fall into the trap of making sure of making the job of diversity the responsibility of the diverse person on the team or yes. diverse people on the team. It's everybody's responsibility.
You can have a pass for that because that's a good point. Yeah. Is the RSE community, does it have a particular problem with diversity when you obviously it has a problem with diversity, but how does it compare to, say, computer science or software engineering? Are we doing a bad job? We're doing a good job? Kirsty? Sorry, Marion.
I need to plug Neil's paper because Neil Chu-Hong from the SSI has published on this. And so what they did is they looked at kind of the fields RSEs typically come from in terms of physics and maths, computation science, and yeah, we do have a problem. We're less diverse than the pools that we're taking them from. I think one of the really important things is understanding why that's happening, what is not attractive about the RSE career, why people aren't being why people don't want to join. There's reasons in itself, but I do think the researcher in me kind of thinks we do need to kind of get to know our community, document our community, and understand the barriers for entering our community if we want to improve diversity. So yeah.
Tom, you happy with that as an answer?
Yeah, I'm very happy. I guess people can't hear me, so I won't say anything.
Tom is happy for those watching online. Okay, so I'm going to move on to the next question. It's changed since last time I looked. This is the wonderfulness of the voting system. Is a PhD still a good way to train researchers or research software engineers? Oh, this is a great question. I asked this question. Are there ways in which the PhD journey could perhaps be improved? So, Sadie, do you have any thoughts?
Well, I was thinking it's probably a good one for me to answer at least a little bit because I don't actually have a PhD. So I think it's important to first of all stress you don't need a PhD to be in an RSE role, which is perhaps quite unusual because obviously you think of people who work in universities, say, or in some sort of academic aligned institution, you'd kind of assume they have a PhD, and people do that all the time. They assume I'm a doctor, which is nice because obviously I haven't put in all that work, but it's certainly not essential. And I think it's best to hear from people who have done PhDs as to I think whether the journey could be improved. But the impression I do get from speaking to people, colleagues, collaborators that have done a PhD and are working in effective RSE roles is that they are very focused on the PhDs they've done, obviously, which varied, but were usually in a domain of science, not necessarily climate science or even environmental science, often things like physics, occasionally computer science. But they are very focused on the domain, and there's obviously this publish or perish culture, and there's lots of pressure to publish when you're doing a PhD. I know this, and I get the impression that software engineering and particularly the good practice side of things is just thrown aside purely because, well, not because people want to not care about that, because they just don't have the time. They're both trying to get through the PhD and often fund it in the background. So one thing from the experience of listening to other people who have done PhDs, and again, it's not essential to do one. And in fact, kind of slightly going back to that diversity question, I think it's nice to have a mix of RSEs where there are people who have different backgrounds, say haven't done a PhD, maybe worked in industry or something else. But for people who have done PhDs, I think, well, this is maybe asking for a real change in culture here, which probably won't happen, but ideally...
Should ask anyway.
Yeah, ideally in future PhDs, they'd allow more time and scope for people doing PhDs in a technical discipline, and particularly like a domain of say, science, maths, to actually focus or have more time to develop software engineering skills, particularly if they're doing coding as part of their PhD, which very often they are. Because I think it's good to ingrain those practices and skills as early as possible, and that way you can develop them gradually throughout, rather than just say someone get to the end of their PhD and thinking, oh, well, actually, I'm going into this role, I should probably start thinking about good practice now, and just try to sort of tag it on at the end, which is, I think, quite difficult. But yeah, we should hear from people who have done a PhD, I should say. Thank you.
No one ever assumes that you've got a PhD as an RSE, do they, Chris?
So I should reinforce Sadie's point. You can actually get to the pinnacle of the RSE career, where you can get to the position I'm in, at least, without having done one, so I only have an MSc. And yeah, that in the case of RSE, that hasn't held me back. And people do make the assumptions. It's continually amusing how that happens here. And when we're recruiting, so we've got, so at RSE level, we ask for MSc or equivalent experience. And at PhD, at senior RSE, we ask for PhD or equivalent experience. And in the last round of recruitment, we had somebody who came in, without a formal qualification, and they did have equivalent experience. And he's a really good candidate.
What's a good way? Because I agree. You both made the same point. It's a very good point. PhD, not necessarily, but the equivalent experience. What is the equivalent experience to get an RSE role? Is it about understanding the research environment? How do you demonstrate that then? Where can you get that type of experience and knowledge? Or what transferable skills can you get from elsewhere that you can help to kind of demonstrate that if you're applying for an RSE-like role? Marion.
I'm sorry, I have an opinion to everything here.
No, it's great.
So I don't agree that you need the research experience at all, because one of my best colleagues that I was so sad to lose to a better job had 12 years of software engineering experience in industry, and I learned so much from her. But I also hope that she learned from me. So we did a lot of code reviews together, and and she would always tell me, you need to put a test there, and I could tell her about the research environment. So I really think that a pure industry background can be equivalent experience. But we also have, so in my previous job in Durham, we've got the junior RSE concept, where we take people straight from university, and they are basically kind of trained on the job to become like a full RSE, which works really well. And to the second question, having done my PhD in Germany, it's really different. So the term of PhD student does not really apply because most of the time you're actually, you are actually employed by the university. You might be on some type of fellowship, but oftentimes you're part of the research group, and you do teaching, and you might do some administrative tasks. I was actually in charge of computation science and engineering master's program and running that. And these things really give you a different type of maturity if you continue on, and they also give you a different type of I don't know, weight or so in your job role, and so because you're really working and you're really contributing to that group and to that research group, whereas in the UK I often feel they are so much still seen as students, and that's not always the better thing. So I think it's good if you have a CDT or these kind of things, you can get training and so, but I think you should let them grow up a bit more. This
was what I was hoping for when I asked the question, that we could kick the current process a bit and say, yeah, it's not quite good enough, right? Because I do worry that with PhD students, I think it's obviously, it varies hugely people's experience, but there's this, you know, we talk about team science, but the PhD journey can quite often be an isolating experience in which collaboration is not a huge part of that. So I think obviously with Centres for Doctoral Training that is kind of vastly improved. But yeah, okay. So I'm going to move on to the next question then, which is how can we increase pay levels for RSEs to closer match the reward for working as an engineer in industry? So should we increase pay levels for RSEs to match what we do in industry? Can we? I don't know. Who's going to answer? That's a really tricky one, isn't it, Kirsty?
I don't feel very well placed to answer it because I'm the researcher turned project manager. I don't have like industry knocking at my door saying come and work for me. I'll pay you loads. I think we need to recognise that it's a transferable skill and it is something that research needs and industry also needs, and industry has very deep pockets. I don't know how we can do it. I mean, the only way we could do it is for the university to be flexible and allow us to pay more, and for the funders to recognise that this is a really valuable skill, and so we can put RSEs on grants and say these RSEs need to be paid at a particular rate. Whether that will ever happen, I have no idea. I think in terms of recruitment, there's a broader, it kind of leads into the second question around why people would choose to be an RSE. I think if we can't do the money thing, we can at least do the flexibility and the really kind of nice working practice and the kind of and to make it as attractive as we can in other ways, and in recognition of the fact that RSEs are very skilled people and they could go off and earn a lot more elsewhere. So we probably can't make it as good as industry. I agree that we should be trying to make it better. In the meantime, or in addition, we should also be kind of maximising what we can offer in terms of recognition, in terms of flexible working, in terms of making it a kind of a nice environment to work in and a really positive experience to work as an RSE.
And anyone else want to make any comments on that?
I'm going to put, since Christopher isn't available, Christopher Woods from the University of Bristol has a perspective on this. Basically, when I left his group and came to this job, I would have expected him to have been disappointed, and fortunately he was at some level. But he also said, yeah, that's part of the reason for the existence of RSE groups in the university is to train up research software engineers that can either remain in a university and help research projects like we've got in this room now, or go into industry and still add value to, in this case, the UK economy, but generalising to any other country, that country's economy. It's still, the skills aren't lost to the country; they might be lost to the organisation, but they are still going and acting as a missionary, maybe for good evangelising good software engineering practices in other organisations. It doesn't necessarily have to be a university.
I think this is, I'm going to come to you, Simon. I've seen your hand is raised. Although we don't have another microphone. Oh, there is one. Okay, excellent. I've almost forgotten what I was going to say. This is a problem of not just RSEs, though, right? This is a problem that is true of academia in general, in that people perhaps feel underpaid and have had ongoing strikes, and they're not just in academia either. So it's perhaps not just a problem for RSE to solve. And on the other hand, I actually feel that as someone who has had more of a traditional kind of academic career and a career as an RSE kind of leader, if you like, I feel I've always managed to do a better job at bringing people back from industry into RSE positions than you ever could with, say, a research position. And I think that perhaps RSE, there's an opportunity to not just have a one-way flow of people going out to industry. I think research environments are really interesting and motivating and inspirational place to work, and there is an opportunity to bring people back from industry, give them that kind of more flexible role and do something that they're kind of deeply passionate about. And it's much harder to do that perhaps with equivalent experience in a research role or going into kind of lectureships. Simon, you had a point.
I was going to say, what if they go off to fintech companies that are doing cryptocurrency hedge funds? That's not necessarily adding a huge amount to the economy, but that was the sort of facile point. But the other thing is, so people stay in academia not because they're paid well, but because there's a lot of kudos to it, right? Getting your name on publications, becoming a professor, these are all great things. What is the equivalent in RSE or associated sort of support roles that is keeping people in academia so that we don't just end up with people who can't get into industry because of lack of talent or whatever it might be? What is the kudos that keeps us here?
But that leads nicely into the next question from Marla, actually. What motivates you to stay in research outside of private industry? So I'm sure that's different for everyone, but does anyone on the panel want to either talk about themselves or talk about other people, teams? What do you think your opinion on that is? Anyone want to volunteer first? Kirsty?
I mean, I think it's obviously it's really individual. I did, when you do like this kind of character things, when you do like management training, you're like, what motivates you? And for me, it came out that it was kind of like I need to feel I'm part of something that's doing something good, and it's cheesy, but I couldn't, and I have worked for companies, but I can't kind of massively motivate myself to do something that's just contributing to company. It's just not who I am. I mean, there's loads of other roles that, I could do that's not academia that would also tick that box. I have worked in academia for a really long time, and it's not always the friendliest environment, and it can be really, really brutal, and it can be really, really hard. But even within that, I find it such a welcoming place. I find that, maybe now I'm a bit older and I can go to a conference, and even if I don't know anyone, I'm fine to talk to people and things like that. But I do find it a very welcoming environment, and people criticise each other's work, and that's, in academia, that can be hard, because you're like, someone's like, oh, why did you do that? You should have done this, and things like that. So you do have to defend your work, certainly as an academic a lot, but it's not normally done, it's seldom done maliciously, it's always done in the pursuit of knowledge. And so I kind of like that. I like the kind of coming together to increase knowledge. I mean, yeah, I think that would be hard to replicate in any other environment, and yeah, it sucks because I could get paid more somewhere else maybe, but I mean, for me it's part of what I am and what I do.
So, Sadie, NCAS is not kind of like a university, right? So it's possibly slightly different there. What's your kind of experience of an organisation like NCAS? Is it almost the same as working in a university? Does it feel very different? Is it more industry-like?
So I'm based at Reading, and I'm kind of paid by Reading, so it's almost like I'm just working as a normal employee of the university, apart from I kind of say get all the emails from NCAS. I get like twice as many emails. But it's, I'll just take back to the original question. It's hard to describe because I've not actually worked at a university on its own. I've only worked, so before I was at the Met Office, I think I mentioned, and I'm now working kind of at Reading as part of NCAS. It's nice to have that extra, I guess, community of people that I'm working with, as well as the one in the meteorology department at Reading. And that is one thing that I do think really contributes to job satisfaction for me, because I think talking about the overall question, what motivates me to stay in research and rather than go to industry, would absolutely be like, it's the balance between job satisfaction and pay, of course. You could pay me, huge amounts, but to do a job that if it was to do a job that I didn't enjoy or didn't feel that job satisfaction with, I wouldn't take that. But I guess it's all about that balance really overall, and I do well, I should say there's also the kind of the RSE communities and all these various communities helping, say, with diversity, the women in HPC, for example, and all of these contribute for me to want to stay in this job of knowing there's some really interesting and welcoming people out there who you can collaborate with and talk to, as well as things such as just the colleagues that I work with on a day-to-day basis being really fantastic, both in NCAS and at Reading, and the intersection between the two. I'm not sure where I'm going with my point, but I think it's really nice to be part of a centre as well as a university, although it does have, again, its challenges in terms of just slightly more admin work on both sides.
Yeah, I definitely think this is a very personal answer to this question. I think it's difficult to extrapolate that out. But Marla, are you happy with that? Is there any other points you'd like us to explore there?
Yeah, a little bit.
A little bit, okay.
A little bit,
Fine.
yeah. Well, it kind of comes back to the diversity, actually, because I think this is a wonderful panel, but in the diversity question, we were talking a lot about there being different ways of making it diverse for women. And I guess I'm also interested in that aspect as women in science. If you feel that being in a university or quasi-university setting is a nicer place, or than being in industry, or if that factors into your decision making at all.
Marion?
Yeah, maybe because I've kind of been there and back again, the misty mountains of industry. For me, it really came, among other things, down to the flexibility and freedom. So, I guess every company is different, but the one that I was in, they were very strict about being in the office and very strict about traveling at all, and also strict about pursuing your own ideas. And so, because if the board didn't agree on this, you weren't doing this, and if the board said drop this, you had to drop it. And I think that was something where I really felt, okay, I'm so restricted, and I didn't feel valued as much in the breadth of things that I had experience with and were interested in. I think it's really also a personal thing. What you prefer and which company you end up in. And but also the other thing that Kirsty mentioned about the feeling, okay, this is actually something good we're working on, and this is bringing benefit for society or the world rather than the company.
So I've never been in industry, so I can't justify why staying in research would be better than industry. But one of the things I think is, if I won the lottery, I don't even buy a lottery ticket, but if I won the lottery somehow, found a winning lottery ticket, I'd buy a boat first of all, and then I'd probably get bored of that, and I'd want to do something kind of intellectually to kind of, well, I wouldn't find myself going into industry. I'd feel myself being drawn back into research, I think. And I think no matter what happened, I'd always feel that pull back into the academic environment and that kind of pursuit of knowledge. Anyway, okay, so next question. Code and data should be made available during peer review / publication. Should the code be reviewed in the same manner as the science? Oh, that's a great question. I'll let you just absorb that for a moment, come up with a good answer, and then who's going to look at me first? You're all looking away, so I'll pick Chris.
So I'm still formulating a response. My instant reaction to that was yes, absolutely. We should hold the code to the same sort of standards we hold the science to. But then I thought about it a bit more. Does it? Yeah. Because classic reviewer number 2, they'll pick on your variable names or things that don't matter. Maybe the tests should be reviewed, and as long as your implementation passed the test, the quality of the implementation is not so bad. So maybe we should focus on the
correctness.
Yes,
Yeah. Okay, Marion.
Sorry, talking too much, I feel. But we've talked about the reproducibility initiative of the supercomputing conference. So I think they started this in 2020, and I've been part of the committee in 2021. And what they are actually doing, so it's they call it the Artifact Description, Artifact Evaluation Committee, and if you sign up for it, and that's kind of voluntary that you do it, you basically have a short description of your artifact, you package up your software and your data, and you send it to them, and then there's actually a committee, and you will have 2 reviewers assigned who will try to reproduce your results of your paper. And there are ACM batches, and I think IEEE has something similar for artifact available, which means kind of, okay, it's there. We can find it, we can access it. Artifact functional, which means, yeah, it runs, we can get it to run. And artifact reproducible, which means that you can actually run it and can reproduce the main results of the paper. Obviously, this can be a big thing if you need to do it on a supercomputer. It's a supercomputing conference. They might have had huge runs there, and so. But there are various then resources available because it's a huge conference, and so. And you can access certain computers and cloud resources, or even in some cases, if it's not possible otherwise, you might actually sit down with the authors and let them show you what they are doing. And I've seen very different things, so from basically things that are kind of in the whole paper in a kind of R script, or others who had then Docker containers or Singularity containers, or so, to things where you're reading through the README and trying to find what's actually producing the results and how on earth you are supposed to get the figures and so. But there is a process, and they've been iterating over this process in the supercomputing reproducibility initiative over the years, and so. And I can recommend to join that committee, but it is a lot of work. So I joined it once, and then the next year they asked me, like, sorry, I'm too busy to do it again.
Just before you go again, Chris, has anybody on this panel reviewed a paper and commented specifically on the quality of code in doing so? Just me then. Okay.
So you said you were going to go first. So but that was going to be my point. Was circling back to the keynote from yesterday from Claire Montelier. I can't pronounce her name. Claire from yesterday. And the EDS book, and so they put a high stock on reproducibility, and I was invited to try and reproduce a paper from there. And the time commitment that Marion talks about is hard. It just fell in a week, which was also ISC and Tier 2 reviewing. And so I wasn't able to devote much time to it. And there's a particular challenge in reproducibility in climate science, because if this was a reproducibility challenge or review thing, where the data set was small and the program was small, I'd shift into through the notebook and say, yes, works. But it wasn't step 1, but step 2 was download this 74 terabyte data set. I'm not, well, maybe the 74 is not the exact number. Well, it was terabytes of data, and I could not do that on my laptop. It was a reproducibility in climate science is hard because of the nature of the domain.
Okay. Yes, Kirsty.
So I think you've both touched on it, but the thing that bugs me about reviewing papers is, as an academic, you get no credit for it. You get no recognition. It takes up a lot of time. If you get an easy paper, a good paper, it can take a couple of hours. If you get a difficult paper, it can take days, absolutely days. And you learn a lot. You learn about how, but I mean, it's still days of your research that you've given up, that you're not doing your research because you're reading this paper. As a system, it doesn't work. It does. I mean, people do it, and that's fine, but it's not, you wouldn't design it like that, would you? It's just kind of evolved like that. And so I think we need to be careful if we're going to introduce that we make sure that the reviewers get recognised for the effort in some way. either see it as a separate part of their role or something that you're like, I reviewed 20 papers or whatever, because it's a huge burden on time. And people are, I don't know if anyone edits a journal, but like it's so hard to find reviewers now because more and more people are saying no, because why would you say yes? It's it's a completely thankless task. And I think we just need to be really careful if we're going to go down that path, how we do it. But yeah, I think it would be good.
I agree. I think we could spend an hour bashing the publication system, actually. But out of interest, everybody here, who reviews papers? And who of those people, still with your hand up, has commented on code as part of a review process? I see. Well, we can be the change that we want to see. If we would like people to be held to higher standards, then when you review next time, make it your objective to comment on the code that they have or have not provided. How about that? Okay. Right then. So next we have, in a world metricized by publications. Oh yeah, we get publications again. How to convince academics to make code fair when they fear being scooped or having their future research ideas used. So this is asking about, let me try and unpick that a bit and get it straight in my head. So this is an anonymous one, so I can't go back. But Jack, oh, okay, yeah, so it's not so anonymous. It's from Jack. I think what you're asking about here is,
well, there was a horrible word limit, so in a more eloquent one, you're saying you want to have sort of things, code made fair, code made discoverable, but everything's metric by publication. So if I've spent time developing a new parameterization or a new big climate model, there's a temptation for academics to want to then keep that wrapped up. So I can publish all these great new discoveries about the atmosphere, but I don't want to make it publicly available because my rival in wherever will nick my model and then overnight do all the experiments I had planned to do, and all that time I'd invested in code development is wasted, etc., etc. How do you convince people that that is sort of not the attitude to take, other than if I can't run your code as an RSE, your rival also probably can't run your code?
Oh, that's a really good question. I really like that. What can we do? What can we do about that? Sadie, do you have any thoughts? But what could we do about that? How do we convince them?
I was just thinking, as any question of persuasion, I think it usually comes down to a carrot or a stick situation, which, if you're not familiar with the English kind of phrase, it's a punishment for not doing something or a incentive for doing something. And thanks for clearing up specifically you were thinking about, I guess, having potentially a rival kind of just copy this reproducible method and do their own research with it, which is something I've not really thought about, because I always think, reproducibility is fantastic, why would you not do that? But actually that's an element of potentially, that's a potential downside to it. I do think it sounds kind of mean, but maybe a carrot might, a stick rather than a carrot, so a kind of punishment for not doing something might be the best way forward, purely because with the best of will, sometimes people can just put something by the wayside, say, while they're just trying to focus on other things, like doing some fantastic research. So some form of potential kind of punishment's maybe a harsh word. It might come down to addressing ultimately the long-term kind of publish or perish issue. Ultimately, that might be the only way. I think I need more time to think on it, to be honest. Maybe someone else can speak while I...
Surely, so if you... I'm thinking of this hypothetical situation. Surely if you publish your model and then other people take it and do really good things with it, that's kind of what we want, right? That's a good story. That's a good outcome. If people are building upon the work that you've done, then it's... maybe it comes back to this idea of kind of research assessment, where, if in that situation, what really you want is to maximise your number of publications, whereas in fact, if you were kind of getting credit for people building upon a model that you've released, perhaps you'd be more inclined to do it. So is it about assessment, Kirsty?
So from my experience with environment, I think there is a fear that someone will take your work and use it. I think there's a bigger fear that someone will take your work and use it wrongly, because it's very easy to run a model. It's very hard to set up a model with the correct settings and the correct parameters. So I think the bigger fear is that someone will take it, use it badly, publish something, and then you're associated with something that's not right, and you know it's not right, and you can't stop it. What people prefer to do is, instead of is to collaborate, and it's a really nice way to collaborate. I think it gets a little bit awkward after a while, because the first paper, if someone's using your tool, and then the first paper, you're a co-author and it's all very collaborative, and then they kind of go and take it in their own direction. At some point you stop being co-author, and at some point you just being someone that's cited. And I think when it kind of grows independent from you, I think it's quite tricky. I think there are fields where you've got multiple groups looking for a single precise answer to some physical thing, and then there really is a race, which group's going to get there first. There's less of that in climate science. It's more about kind of a general understanding. So a lot of the skill in building the model, but then there's a skill in designing the experiment around the model as to what exactly you want to do. And I think in general for climate science, it's less of a being scooped. I'm not going to be the first person that calculates this with this model. It's more about how they're using the model, whether they're using the model well, which is really, really hard to control, I think.
So I'm going to kind of go off on a tangent with this question, and because I'm chairing, I can. But I see some parallels with this with kind of... so okay, I'll back up a bit. So in engineering, what I discover a lot with people's code running an RC team is people say, I don't want to share my code because I'm going to sell it and I'm going to make loads of money. And no, you're not, right? First of all, you're not. But there are genuine cases where there is opportunity for kind of innovation and IP protection and creation of new spin-outs from research and so on. And perhaps that doesn't happen quite as much in climate, but that's certainly something that happens in research. It's certainly something that happens in a research environment. So how do we balance that need for people to kind of want to pursue that angle and also produce fair pieces of research or fair pieces of software? Can you? Is it impossible?
I was just going to pick up on one of the many points you just made, and just add yet to it. So the fact that you can't generate some IP which will get you massive income in the climate science area probably has been true, but there's a lot of climate tech out there now. There's a lot of money rushing into the scene because of the situation. So it might well be that we do face this challenge and this problem, people with that motivation, more than we have done.
What's the answer then? Do we ask people not to, do we ask people not to publish? Do they hold things back? Is there a way that they can publish and still pursue commercial endeavours, or? Kirsty.
Sorry. I presume you can be clever with licensing. For me, it depends a lot on who's funding your research. If you're funded by, one of the kind of the main public funding bodies, then to then take that research and make a private profit out of it is ethically challenging, I think. Though the university technically holds the IP rights to what we do generally, at least at Edinburgh. So there is that kind of, there is that support. I guess, for me, the fact that you've been kind of given public money to do some research means that research should be in the public domain. And I'm a bit naive, I know.
I think the counter argument to that is that there is a public interest in creating new industry and creating new jobs and kind of creating new kind of economy around that. But I don't know. I don't know what the answer is. I wondered what people's thoughts might be on this. But I certainly think licensing can perhaps play an important role, and that's probably true for those people that kind of keep their code behind, or want to keep their code behind closed doors so that they can kind of produce papers as well. Perhaps clever use of licensing can be a way to mitigate that. Okay, so, this is a great one. Can you give an example of what can happen if research software does not follow good practice?
the rocket blows up. Or, yeah, that's it. Well, some of the Ariane 5 blew up because there was an issue when they went from 16-bit integers to 32-bit integers. They just copy-pasted the software from Ariane 4 to Ariane 5 and didn't consider the integer underflow. No, not integer floating, but yeah, there was a variable size issue, and the rocket blew up because of software. Going back to my colleague Christopher Woods, he has a talk called Scare the PI. That's not the title of the talk, that's how he refers to it internally. He has it in his deck of talks he regularly gives when he goes out and explains why you would want to do this research software engineering, why you want, if you're a researcher, why this is important. And it's basically just slide after slide after slide of retractions and researchers who are wound up being embarrassed about a result that didn't hold up because the correct attention wasn't paid to the software at the right point. So in the worst case, in the worst case people die.
Does it put people off, do you think, seeking professional support from an RSE, knowing that they have decades of publications perhaps based on a piece of software which hasn't necessarily had that critical eye over it?
Sadie just had her hand up.
Sadie?
Oh, that was to, I guess, more general question.
Oh, no,
but I'm sure it would.
We can come back to that.
Oh, sure. So I was going to say, obviously, as Chris has said, one of the worst case scenarios, obviously, is the lack of good practice leads to software not working, not being correct, and catastrophic things can happen. But I was thinking maybe in terms of the wider context and the longer term. One thing I think that can happen and is potentially just as, well, not just as bad and negative, but can be really difficult to resolve in terms of a problem is kind of demoralization of researchers and research software engineers. So if you're working in roles on a project where there's not the good practice there, or there's not enough of it, that it leads to software and systems where, say, things are full of bugs or things aren't working properly, or it's just a nightmare in the sense that you, say as an RSE, feel like you're constantly having to firefight things or do menial bits of work that are just not intellectually stimulating even, because obviously we're all clever people and we really like to work on things that are, say, the forefront of research rather than just kind of doing a linting fix or something that's really tedious. So I've seen in a former workplace that I may have mentioned, but I'll not pick on by mentioning their name again, this case whereby people were working on libraries where there were issues with lack of good practice. And in my opinion, obviously I don't know the full story, but I do feel like that contributed to a lot of the staff leaving and there being this very quick turnover of staff. And of course, when you have new, say, RSEs, researchers come in, there's that training period where they're getting spun up on using some software and the relevant tools and libraries, and it takes time to initiate people. And obviously, people are most productive once they're really familiar with tools and libraries that they need to use. So it ends up with this almost cycle of staff having to come in, getting trained up, getting demoralised, leaving, and just in a bit of a cycle. And of course, with a high turnover of staff, that leads to software systems themselves being more run down and having more broken windows, as they call them in. It's the Pragmatic Programmer, which is a really good book on kind of good practice. And eventually, well, there's lots of libraries you see that just eventually just kind of get deprecated and die because people stop using them, people stop maintaining them. Probably maintenance stops first.
So it's not just the output, then. It's it can affect the whole culture of the work environment, really. If there's bad code and people don't believe in it. Yeah, Chris.
I want to drop Kirsty in it because I think she's got a good opinion. Because this was part of your previous talk. What happens if we don't follow this is people don't have confidence or trust in our advice, and how bad would that be in the context of climate?
So I was thinking of like the worst kind of bug we'd ever had in GLOMAP just then, and we didn't put a limit on growth, so all our aerosol coalesced together. We just had this one giant aerosol like bouncing around the Earth system. It took us a little while. It was before we'd published. I have to say we did fix it. Yeah, no, I think it does erode trust, and I think that it's hard to do. I mean, I don't tend to talk to policymakers, but I do a lot of public engagement and schools engagement and things like that. And if you can stand up and say, you know, this is what we're doing, it's here, it's open, we're really being open about the processes that we're taking in this, then you can't expect people to trust you. And especially if you're speaking to people that aren't particularly familiar with the scientific process, or maybe a little bit sceptical about the scientific process. And I mean, if it applies to school kids and you know, public forums, then I suspect it probably applies to policymakers as well. Like, I think the worst thing that can happen is that fundamental misunderstandings go unnoticed and unchecked. I think in terms of scientific, you can have errors which become propagated and people start to believe them, and you know, that's the worst case scenario. You open up your code and then suddenly the fear is something's fundamentally wrong with it, and that shouldn't happen because you should have tested it enough ways, even if it's closed. But you don't want to be providing information that's then looks really bad departmentally. If you provide information, then you have to say, oh no, sorry, we realised that this isn't right and this isn't right. It does erode trust and it erodes confidence in terms of how open we can be, and it kind of comes back to being open about uncertainties as well. Like, you know, we know that there's uncertainties, but we can be open about those as much as we can, and we have more confidence to be open about what we don't know if we're confident about what we do know.
Has anybody discovered a bug in a piece of academic code that's meant that they've had to do a retraction? Oh man, just me again, okay. Right, so, next question, Dan. How would you redesign the formal doctoral and postdoctoral training for the future needs of climate modelling? Ooh, that's a tricky one. Well done, Dan. We'll have a moment just to let people absorb that. How would you redesign the formal doctoral and or postdoctoral training for future needs of climate modelling? Anybody like to have a go on have a go at that? Okay, Kirsty, come to you again.
I mean, just a really simple ones, as I would encourage, like movement between groups, internships, things like that. So we used to do, I forget who was funded, probably EU funding, and one of the conditions was that the student had to go and spend 6 months or 3 months even in industry. So they went to work for like a company that developed, you know, atmospheric, what they called instrumentation, basically. But I think if you can have the experience of working in different research environments, going to a different group, it's brilliant, because you learn, not only you learn new science, but you learn their working practices, and the more you expose yourself to different working practices. So, I mean, it has to be in addition to the PhD time. It's not full PhD time, but I would love to see some internships and some more movement between RSC teams and research teams back and forth, and more movement of students between different research groups, because it opens up, if you, a student, although they're really busy, have more time to go around the department, speak to lots of people and kind of get to know it. It opens up science, it builds collaborations. Collaborations built from the kind of grassroots up, I think, are really effective.
Sadie, yes.
I was just going to essentially say I completely agree with Kirsty, and I think for me I'm not actually familiar with the doctoral and postdoctoral training we have at the moment, but even in the UK, again, I've not been through, well, I'm on a kind of RSC career track rather than a postdoc track myself. But I think collaboration is just one of the key areas to, I guess you can't really train people in, but get them involved in building up kind of, well, as many collaborations as possible, because obviously the climate modelling community is international. I completely agree with what Kirsty said. If there's a way to integrate that into the training as much as possible, I think that would be really good going forward and important.
So has anyone got any good examples of how you can kind of do that effectively then? Any programs or experiences that can share? Marion?
Yeah, I was quite lucky when I did my PhD that I could join doctorate training program as associate, so not as a fellow, but as an associate, which actually allowed a 3 months stay abroad. So I spent 3 months with another research group abroad, and that was really helpful in terms of seeing something else and seeing a different way of doing research and working together, and also meeting new people and meeting people that I continue to do, to write the paper together and so, and meet at conferences and so. And I think, it's probably a money thing as well to make this possible, but I think these kind of programs or possibilities can enhance research quite a bit.
Fantastic. Sorry, I wasn't laughing at your answer, I was laughing at the next question, which we have to ask. Why is Python the best programming language? Like, why is it just so good? I'm going to look around the room and guess that Dom asked that question. No? Okay. Oh, no, sorry, I thought it said Fortran. Yeah, okay. Who would like to talk perhaps about the importance of Python as a language? Is it important as a language?
Yeah.
In climate science? Doesn't it do everything wrong? It's too slow.
It's just not fun.
So, it is too slow. If you insist on doing all the computation bits in Python and not use any external libraries, even the Python provided ones like NumPy. So if you re-implement what NumPy does in pure Python, then it's too slow. Why is Python the best programming language? I don't think there is a best programming language. There are good programming languages for certain situations, and maybe Python is the best programming language for teaching novices. So that's what we did at Bristol. We taught people how to program, and we taught them in Python, mostly because we came from a STEM background, and even though in Bristol they had a lot of public health stuff and a lot of R, the research group there, everybody knew Python, so that's what we taught. And because it didn't have such, when you're having to teach somebody Hello World, you really want to be introducing just 1 or 2 new concepts at a time, and if you have to introduce what the hash character is, and then the include, and why the thing is in between angle brackets, and then why it says int and then main, and why this brace is a curly brace versus the other ones which is square brace. That's all way too much overhead for a beginner to learn. It's cognitive overload. So in Python 2, you could actually just say print hello world. Python 3, now it's a function. You have to explain the round brackets, but it's still 1 line of syntax. So it's a good language for teaching novices. It's got enough libraries for data analysis that I would say possibly a majority of researchers can do their work in Python. Now, there may be better languages, better library support for different areas. So if you're doing statistics, I'd absolutely say learn R. If you're doing something computationally heavy, I would say learn a compiled language rather than an interpreted one. And I have an interest in energy usage of computing, and there was a lot of noise a couple of years ago. There was a paper in Nature Astronomy, I think, from somebody plotting programming languages versus their energy use, and basically saying the astronomy community should stop using Python because it's just so bad for the environment. I think a lot of people took the took that message from the paper, and that's the wrong message. I think you use the programming language that's appropriate for the thing, and Python is a great glue language for calling out to others. You can have all your heavy lifting written in C++, and you can use PyBind 11 or something else. Yeah, sorry.
So Chris says there is no best programming language. Surely someone has a controversial opinion to disagree with that. No? Python does do a lot of things right. Sorry, Sadie, yes.
No, I was going to say, I could add that Python is my favourite, but yeah, I wouldn't say it's the best.
Yeah, I agree. I think it's very accessible, and I think it's better than Excel. So
That's a low bar.
Yeah.
Can I just add, I'm going to come to you, but I actually have some code written in C++ with Python bindings. It's actually faster in Python than via native C++, and that's GPU code as well, so I will explain the reasons for that over lunch. Kirsty.
So I don't have an opinion in terms of programming languages, but I think it is worth considering where the slow parts of the research process are. So part of the slow part is how long it takes to run on a supercomputer. That's important in terms of energy use, and it's important in terms of time to science. But in terms of going from an idea to a scientific publication, the slowest bit is the human part. And so if you have a super efficient language which runs really nice on a supercomputer, but people can't code in it, people that aren't good at coding can't code in it, then it actually makes, although it might make the computational bit faster, it makes the time to science slower because there's more mistakes. And so I think the more readable, human readable your language is actually really important in terms of who's using it, because you're not, even if you're writing code for someone, you're not writing code for someone that is a software engineer. So it might be something that software engineers might be able to think, oh, that's beautiful, it's really readable, I can understand it. But someone that's not good at software engineering might be like, oh God, there's a lot going on in that, and it's easy to make a mistake. And I think that time, those mistakes, just eats research time. It really does.
I've just got one quick thing to add. Since we've got some Klima people in the room, I think we can't not mention Julia in this context, which aspires to have the ease of use. You're talking about time to science and programmability. The ease of use of Python with no less than half the speed of C. I think that was the initial claim.
It must be really good, because I don't know anyone that uses Julia that doesn't subsequently have a T-shirt or sticker or tell me at every opportunity that I should use Julia. So it must be really good. Yeah. Okay. So I'm going to ask another question about, but in a few minutes we'll kind of bring this to a close, and I'm going to ask the panel if there's anything they'd like to say, just kind of a 1 or 2 minute summary, if there's any points they'd like to re-emphasise. So if you want to have a bit of a think about what you might like to say as well, think about 2 things at once and try not to muddle them up. Okay, so does becoming an RSE shut me off from an academic career in the future? Ooh. Sadie.
I could potentially talk about almost the opposite, because so to provide my experience, which is anecdotal, but it was hopefully useful to hear. So when I was at university, I studied physics, did a master's in that before I went to the Met Office for 2 years. And actually partly because I was quite ill throughout that degree, I didn't get very good grades, and I'd always wanted to do, I'd always wanted to do a PhD. I think since getting to upper school, I think I always saw myself doing a PhD, but actually with those grades, it would have been difficult for me to find one. So I kind of thought, well, I'll go and do a job in coding, which I like. And so via becoming a scientific software engineer at the Met Office, and then going to Reading, I've kind of worked my way back into kind of a university and academic environment, whereas otherwise I might have been kind of not forced out, but that door might have been shut for me. And certainly going forward, I personally have been told that I could apply for a PhD at my institution. One could be done even on the job. I know a colleague who I believe did one on the job. Obviously, take longer than a standard one. Maybe not answering the question itself, but almost the inverse is that actually doing a job as an RSE can open doors academically for you as well. Although I guess there is the question, which someone else might want to perhaps cover, of obviously the different career tracks. So on an RSE career track, you're not going to go through kind of a postdoc and then I'm not sure what they call it, but I think it's a lectureship and then a professorship, which does kind of remind me potentially of a side point of, so a colleague I have at NCAS who is, I believe at Cambridge actually, recently got a promotion, and they're effectively a professor, but they're not being called a professor, which I found quite interesting because it's almost like they are professorship level. And I think it'd be nice, everyone would be like, oh, I'd enjoy being called a professor, but they don't get that. They get a fancy title, but it's not professorship. So that's a slight tangent to what I was saying. But inverse-wise, there are real opportunities there.
Been a part-time professor. I can only use it occasionally. I do think that there's a lot of kind of diversity across research institutions and that in terms of how they support that career pathway and what career pathways look like and where RSEs sit. There's a huge amount of there's no kind of one size fits all, if you like. I don't think, and I often describe that as a great challenge to RSE, but also a great strength, because it means that we do have a huge amount of diversity in the community. And I don't know, would there be a reluctance to try and kind of standardise that across all places? You can answer either question, Chris.
I was going to go back and answer the first question with a counterexample from our program from, I think tomorrow. Jim Denham, was an RSE in ICCS at the beginning of the year and is now doing a postdoc, I think, and his affiliation is AstraZeneca. So,
And Cambridge. It's Cambridge.
Yeah.
Chris, to be honest, how long he was an RSE?
Yes, he was only an RSE here for 4 months, but still, that did not shut him out from having an academic career. So.
No. Marion.
Yeah, I think that points towards maybe the point at which stage in your career you're doing that. So I think if you're doing an RSE type job at a PhD or early postdoc level, that might still work. But at a certain point, if you want an academic career, you need publications and you need your own research field. So if you're, for example, in a central group, you're working on lots of different research fields, and so that might lose your own research because you no longer have the time to do that, and you might be on some papers somewhere down the author list, and so, but you no longer write your own papers that much. And also you might not want to go back to being a postdoc or even an assistant professor because you've progressed in a different type of career to a certain level, and you don't want to go over and down to go to the academic
At last, an opinion I
path.
could disagree with, Marion. So, I don't agree. I don't think to become, reach the heights of academia that you have to have a specific domain. I never did, and I was insistent that, if I kind of go through a promotion process, and in my previous institution, I was an RSE, but I was on a research pathway, which meant that there was a research promotion pathway. I didn't want that to be about a particular domain. I was insistent that it was about collaboration and kind of breadth rather than depth.
Yeah, interestingly, when I applied to an assistant professor position years back after my postdoc, being interdisciplinary was actually a negative thing. So they asked me, okay, so those papers that you've written, so how much would it count into our ref rather than the other ref? Because it was, I was on the department for mathematical sciences, and it was a kind of a physics thing, but I applied for a computer science assistant professorship. So it's how much would it count into our computer science ref? And so, and they really didn't like the interdisciplinary bit.
I can understand why you would come up against that, but I think there are some important tools that we have as RSE. So one is San Francisco DORA, which is an initiative that almost every institution has probably signed up to, that states that researchers shouldn't be judged just on kind of publications and publication impact factors. And it kind of puts pressure on institutions to make sure that they're being more aware of the range of research outputs that exist, because researchers don't just produce papers, they produce code, they produce data sets, they produce musical performances, they produce all kinds of different outputs. So I think that's a useful tool that you can use. I think that there should be more pressure to kind of make sure that that's reflected and understood and rewarded within a research environment. But also, if you listen to kind of the things coming down from the top, so UKRI have published, I forgot what the policy is about kind of investment in people, and what they want to see is they want to see academia as somewhere that is not this one-way flow of, of people that we train and then go out. That's an important part of what academia does, right? We have to train people to go out and but we want to get people back in. So, like, does being an RSE shut you off from academic career? Possibly narrows the door. You possibly have to have an awareness, but it shouldn't. And there is a desire that it shouldn't.
There's a lot of should in that.
Let's see more examples of people that are kind of coming back in, and let's see more examples of people coming back in into academic careers and moving between the two. I'd really like to see that. Okay, so we are approaching the end of this session. So I think what I'm going to do is I'm going to first of all thank our panel. So. And I'm going to give each of you a minute. If there's any point that you would like to very quickly summarise that we've kind of gone through. I'll start at the far end, Marion, if there's anything you'd like to say.
I don't know. I think it would just be great to keep that discussion open. And I don't know, maybe in the Slack workspace, or discuss something like a repro hack, or kind of just getting questions from you. So there are the RSE office hours, I think, today and later in the week as well. So please go there and ask questions and come up with ideas, and maybe also with things that you need from us as ICCS. So what would help you, basically, or what are your questions in terms of getting better at something, or getting training at something, or doing a kind of workshop or event. So please talk to us.
Sadie, anything that you'd like to add, or?
I'm just checking on the title of this overall was about good practice, software engineering good practice, and I think I'd just maybe highlight that it's the kind of thing that if you see other people engaging in good practice, then you're much more likely to do that yourself. So I think try and just be a role model and apply as much good practice as you can. Obviously, it's not just a static thing. You have to keep up with trends. For example, like continuous integration is a lot more common now than it was, say. So always keep it in mind and devote some kind of professional spare time that you get towards that. And hopefully the community can continue to thrive with good practice, and the bad practice can be less common.
Excellent.
Yes.
Chris?
The danger of going after Marion is all the good points have been taken. So I'll reiterate them. We do have a Slack workspace, the Vesri plus Klima Slack. Everybody is invited. You can contact us there. While you're here this week, we do have our RSEs available for consultancy for the office hours. And yes, take advantage of the opportunity of the ICCS Summer School to improve your practice and do that demonstration of good practice so that others can see.
Kirsty, you've got the hardest job.
I was going to do an easy plug for the wider RSE community, because I mean it's brilliant. There's so much knowledge and so much experience in this room, and there are kind of domain-specific RSEs, but it's also the wider community in the society is actually a really, really friendly and welcoming place. So do come along to events. There's loads of events. There's an RSE conference in September, but join the Slack space as well. There's loads of stuff that goes straight over my head, but there are quite a lot of really interesting discussions, and when I have asked questions there, it doesn't have, obviously it's not domain specific, but there's so many people on it. It's a really great repository for information of people willing to help. So yeah, do check it out.
Totally stole what I was going to say. Yeah. Okay, well, just one more time, I'd just like to thank the panel again. So thank you very much, panel, and then we're going to break, so thank you.